Hi everyone. So just like linear equations can have a system, linear inequalities can have a system. So let's review what type of lines linear inequalities have. So if we see a symbol that looks like this, the line is going to be dotted, and we're going to shade below. It means less than. Okay. If it is greater than, this one means greater than, it's going to be a dotted line. And it means that if it's greater than, we're going to shade above. Okay. And then if it is less than or equal to, okay, so if it's equal to, it means it's included. It means it's going to be a solid line. It means it's going to include it. Okay. That has nothing to do with the shading. The less than means that we're going to shade below. The or equal to means that it's a solid line, and the less than means that we shade below. Now the greater than or equal to, the greater than part means that we shade above, but the or equal to makes it a solid line. Okay. So we had to determine, is it going to be a dotted or solid? It's the first thing you need to do. Is it going to be a dotted or solid line? And then are we going to shade above or below? And all you have to do think is if it's greater than, it's going to be above, and if it's less than, it's going to be below. Okay. So we have a couple of inequalities here. Let's have a system of inequalities. And so we are going to determine the solution area, because remember, inequalities have a whole area. All right. So we have y is less than or equal to 2/3 x plus 2. So in your calculators, you're unable to graph an inequality whenever you have your Presta test turned on. So I've graphed it as a line, okay? And then y is greater than or equal to 3 minus x. So I've graphed that one as a line, okay? So we have to figure out which way we have to shade. So if it is less than or equal to 2/3 x plus 2, okay, I have to start at my y-intercept, which is at 2. I'm going to start here at 2, and this is less than. So since it is less than or equal to, I'm going to shade below. All right, so I'm going to start here, and I'm going to shade below. So everything here gets shaded below from the blue line down, okay? Everything. All right, so that takes care of that inequality. All right, now, for y is greater than or equal to 3 minus x, I have to begin at the 3, which is this y-intercept. Now it's greater than or equal to that 3. So since it is greater than or equal to, I have to shade above. So I'm going to begin here, and I'm going to shade this way. So everything on this part of the line is going to be shaded. Okay? All right. So notice what happens. Just think about what's happening there. Let's answer some questions. So our first question asks, where do you think the solution area is? Oh gosh. All right. So where do you think, give me just a second. So where do you think the solution area is here? If you were guessing first, where do you think the solution area is going to lie? What do you think it would be? Well, if it were me, I would think that it would be in this green area right here, and that is where the shading overlaps. Excuse me. Okay. All right. So then we have to see where the coordinate of the intersection is. Well, so I'm going to go over here to my calculator I have here. Let's see, I need new graphs. I'm going to graph these. Man, I had them graphed a while ago, didn't I? Ah, 2/3 x plus 2, and then 3 minus x, and then menu, analyze graph, intersection. Man. So the coordinate of the intersection is at, is it 0.6 and at 2.4. If you want to live in fraction land with me, that is at 3/5, 12/5. Okay. Either of those is acceptable. So now the next question asks, are the lines included in the solution? So this is a or equal to, right? It says or equal to. So does that mean that the lines are included in the solution? Absolutely. Yes, because they're solid. Yes. Because the lines are solid, they're included in the solution set. So I want you to name a point that is included in the solution set. So we look at this and we want a point over here. Oh gosh, let's see. 1, 2, 3, 4. Let's go up here. There's a 4, 1 right there. 4, 1. 4, 1 is over here in that green area. 4, 1 is in the solution set. It means that if you plug in a 4 for x and a 1 for y in this one, it makes it a true statement. A 4 for x and a 1 for y in this one, it makes it a true statement. Any x and y value that you plug in this green area or on either one of these lines is going to make these true. If it's over here, it's only going to make this one true. If it's in just the yellow part, it's only going to make this one true. If it's over here, it's not going to make either one of them true. All right. Okay, let's move on. Let's go to the second one. All right, so I've gone ahead and graphed these real quick. But what I need you to do is I want you to solve these for y. All right, so we have to solve for y before we can even graph anything in the calculator because we're not able to graph as a relation. All right, so I'm going to want you to pause the video, solve for y, and see how you did. This is your practice for solving for y. Okay, so I'll come right back and we'll see how you did on the solving for y part. Okay, so these are solve for y as far as an inequality. So y is less than 7/3 minus 4/3x, and y is less than 8/5 minus 3/5x. And the reason I did that is because I wanted to graph it in my calculator. Okay, so I want to know what the point of intersection is. My point of intersection was at 1, 1. And then the next question says, are the lines included in the solution? Now on my calculator, you'll notice that they're dotted. Oh, no, they're solid. I can't graph as a relation. So that's why they're solid there. I made some magic happen over here on the on OneNote so that you would actually see what it should look like. So the lines over here are dotted. So are they included in the solution? No, they're not, because they're dotted. All right. So if I were graphing these, so this is y is less than 7 over 3. So if it's 7 over 3 is my y-intercept. So this is my y-intercept, right? So it's less than. So that means that I am shading below this. All right, so I'm going to shade below this blue line right here. All right. And then it's y is greater than, or greater, just not or equal to, just greater than 8 over 5 minus 3 over 5x. Okay. So that is going to be right here. So it's greater than, so that means above the red line is where I'm going to shade. All right. So everything above the red line is where I'm going to shade. So if we think about this, okay, you can see where the solution area is now because of where it overlaps, right? You can see how I erase the lines too now. All right. So what they want us to do is name one point that is in the solution set. So let's find a point that's there. There's one right there. What is that point? It's a negative 2, 1, 2, 3, 4. That is negative 2, 4. Negative 2, 4 is in the solution set. That means if you plug in a negative 2 for x and a 4 for y, it's going to make this a true statement. Okay, negative 2, 4 will make that a true statement. Negative 2 for x and 4 for y will make this a true statement. Okay, you can try it. Okay, all right. So you just have a couple of practice problems here. Let's look at those real quick. Number 1, what is the point? What point is in the solution set for the system of inequalities? Let's look at it. So we go to 5, negative 1. Is that in the solution set? No. Is negative 1, 5 in the solution set? No. For the system of inequalities? No. Negative 5, 1, is that in there? Well, it's where it overlaps, right? Looks like it. 1, negative 5, that's not, is it? So the one that is in both of them is going to be C, because it is in the area that overlaps. All right. So then they want to know which one of these is the system for that graph. Okay. So we have to solve for each one of these and see which one matches up, right? So the first one we have x plus y is less than 3. So I mean, this is a lot of work, y'all. So we have y is less than 3 minus x. And then we have x minus 2y is less than 0. Let me get this eraser over here. Get rid of this so I can solve for y over here. Negative 2y is less than 0 minus x. So negative 2y is less than negative x. If I divide by negative 2, don't forget my sign swaps, right? So I have a y is greater than a positive 1/2 x, right? Let's see if this matches up. So my y-intercept for this one would be 3. Oh, that's true. My slope is a negative 1. Okay, so this one matches up. And then I have a y-intercept of 0. That's true right here. And then my slope is 1 over 2. Oh, man, y'all, we lucked out. The answer is A. The answer is A. Okay. All right, so that's it for today. See you on the next video.